I want to explain how I ship open source tools with AI, because the answer is much less glamorous than most people expect. I am the founder of Talicode, and I learn by building. AI is part of that process, but it is not a shortcut around judgment, testing, or responsibility. It is a collaborator that helps me move from a rough question to something I can run, inspect, document, and share. The starting point is always a practical problem. I do not begin with a giant platform diagram or a claim that a tool will change everything. I start with an annoyance that keeps appearing in real work. Maybe an agent needs a reliable way to remember something. Maybe a workflow needs a small guardrail. Maybe a repetitive task deserves a command line tool instead of another manual checklist. A useful tool begins with a specific job someone can recognize. Then I make the smallest version that can prove the job is possible. That means one input, one expected result, and one path through the code. It is deliberately narrow. A narrow tool is easier to reason about, easier to test, and easier to explain. AI helps here by accelerating exploration. I can ask it to propose an interface, sketch a test case, point out edge cases, or help turn an idea into a first implementation. But I do not treat the first answer as the product. I run it. I read it. I change it. I keep asking what happens when the input is wrong, missing, too large, or surprising. That is the first principle of my workflow: use AI to increase the number of experiments, not to lower the standard of proof. Fast generation is only useful if it creates more time to validate. If a tool cannot survive a small real test, a polished landing page will not make it useful. Once the core path works, I try to make the behavior visible. I want a person to be able to see what the tool receives, what it does, and what it returns. That might be a command they can paste into a terminal. It might be a small example file. It might be a short recording of the workflow. The format changes, but the rule stays the same: show the mechanism, not just the conclusion. I would rather ship a modest demo that someone can reproduce than make a big promise that cannot be checked. Open source makes that standard more important. When code is open, the work has to stand on more than a headline. People can inspect the repository, try the command, read the issues, and decide for themselves whether the project is useful. That is healthy. It pushes me to write clearer interfaces and to leave a trail that explains why a decision was made. It also means I can learn in public without pretending I know everything in advance. Learning by building is not a slogan for me. It is how the roadmap gets made. I build a small capability, use it, notice where it is awkward, and then improve the next version. Sometimes the lesson is technical. A dependency behaves differently than expected. A command needs a safer default. An example is too complicated. Sometimes the lesson is product related. People do not need another dashboard, they need a reliable action. AI can speed up the loop, but the loop still depends on using the work and listening to what breaks. The next part is documentation. I treat docs and tutorials as part of the launch, not as cleanup after the launch. If I cannot explain the tool in a short getting started path, the tool probably still has too much hidden complexity. Documentation forces useful questions. What does this do in one sentence? Who is it for? What is the first command? What should success look like? What can go wrong? Those questions improve the product as much as they improve the README. For every tool, I aim for a simple proof path. Someone should be able to go from a problem to a working result without needing a private call or a long explanation. That usually means a clear install step, a minimal example, and a visible output. A tutorial is not marketing copy around a feature. It is an executable promise. If the tutorial is confusing, the product is not finished enough to ask other people to try it. Video is part of that proof path too. A short demo can show the actual workflow faster than a paragraph can. I use videos to walk through the input, the command or interface, and the result. The goal is not to manufacture excitement. It is to remove ambiguity. Viewers should leave knowing what happened and whether it relates to their work. That is why I prefer practical screen-level proof over vague claims about what AI can do. There is also a discipline to keeping the scope small. AI makes it easy to generate 10 more features before the first feature is solid. That temptation is real. A better question is, what must be true for this tool to earn one more hour of work? Usually the answer is not a larger feature list. It is a test, a fix, a clearer error, a better example, or one real person successfully using it. Small proof compounds. Feature piles do not. When I use AI for code, I give it concrete context. I describe the existing interface, the constraints, and the exact behavior I want to verify. I ask for alternatives when the trade-off matters. Then I compare the output against the repository and the tests. I do not want an impressive-looking patch that quietly changes the product. I want a change I can explain. The more consequential the change, the more I slow down and verify it. That verification can be simple. Run the command. Exercise the unhappy path. Check that the output is understandable. Read the diff. Make sure the docs match what actually happens. If there is a public example, run the public example from a clean starting point. These are ordinary habits, but they are what turn assisted generation into software people can trust. I also try to be honest about the stage of the work. An early tool can be useful without being complete. A tutorial can explain a known limitation. A release can say what it does today instead of implying it solves every future problem. That kind of honesty is not a weakness in open source. It gives contributors and users a real starting point. It makes feedback more specific, and it protects the work from hype that the code cannot support. The rhythm I come back to is simple: notice a practical problem, build the smallest useful version, test it in the open, document the path, record the proof, and listen for the next problem. AI shortens parts of that cycle. It helps me learn faster, write faster, and explore more options. But it does not replace the part that matters most: choosing a useful problem and being accountable for what ships. That is how I am building Talicode. Not by claiming that AI does the work for me, and not by waiting for a perfect master plan. I build practical open source tools, use them, improve them, and make the learning visible through docs and tutorials. If you are building with AI too, focus on the workflow someone else can verify. Make the first useful thing small. Show it working. Then ship the next improvement from what reality teaches you.